Hello everyone, welcome to MK Maths. I am Karthik Mansali. In last video we have discussed about the types of a function, one function, onto function and bijective function. If it is not one function, we name it as a many one function. If it is not onto function, we name it as a into function. We have all discussed in a previous video. So before going to 5 marks, before going to start a 5 marks, let us understand about the domain and range concepts. Because domain and range concepts will be very important role to understand the relation and functions topic, because through the help of a domain and range only we are going to solve a 5 marks questions. We are going to solve this to show one onto functions, bijective functions, all those things. So for that we should have a minimum and basic understand of domain and range concepts. So let us understand with the example. So what will be the domain and what will be the range for both relation and as well as function, how the relation we can call it as a function and which relation we can't say it is a function. So those things also we can see now. And also let us see how to denote a function. So how to denote a function in easy way, also how to represent a function also. Okay, so here in this example, in this particular examples, I have considered, here I have considered a. So here I considered set a 1 comma 2 comma 3 and a set minus 4 comma 5 comma 0. Any elements you can consider, there should be some elements. That means a and b should be non-empty. So I have considered 3 elements in a and 3 elements in b. Okay, so I have created two relations here, r1 and r2. So these r1 and r2 are relations because this r1 is subset of a cross b. You observe if you observe r1, so r1 is a subset of a cross b and this r2 is also subset of a cross b. So if r1 is a subset of a cross b and r2 is a subset of a cross b, means we can call it is a relation. So we both r1 and r2 are a relation here. So it is satisfying the definition of a relation, because to satisfy the definition of relation it should be a subset of a Cartesian product. So if you observe the ordered pairs in r1 and if you observe the ordered pairs in r2, those are all contains in a cross b, Cartesian product a cross b. Okay, so r1 and r2 are relations here. Okay, so let us check the function. So which r1 is a function or not, r2 is a function or not, we have to verify now. So how to verify the given relation r is a function? First, to define a function, the given set must be a relation. So obviously here r1 and r2 are both are functions. So sorry, r1 and r2 are both are relations here. So with the help of a function definition, now we are going to conclude this r1 and r2 in which r1 and r2 function itself. Okay, so here if I consider r1, first example r1 contains three ordered pairs here, 1 comma minus 4, 2 comma 5, 3 comma 0. If you observe clearly from each ordered pair, so first element 1, this first element 1 comes from the first set A, and this second element minus 4 which comes from the second set B. It means this is a relation from A to B. This R1 is a relation from A to B. It starts from A and it ended to B. It is starting, the relation is starting from A and it ending in B, elements of B. So if you observe the second also, this 2 is contained in A and this 5 is contained in B, and this 3 is contained in A and this 0 is contained in B. It means first elements of order pair, first elements here are 1, 2, 3, these are all from A. Second elements means minus 4, minus 5, 0, these are all from B. Okay, so here function definition says every element of a. So if you watch my previous video, I have explained already definition of a function. That function, the definition of function says every element of a. Every element of a means here a having a 1, 2, 3, and in our relations we have used 1, we have used 2, and we have used 3. Every element of a is satisfied here. So first condition is satisfied. Next, every element of a has one and only one image in B, one and only one image in B. So 1 having a minus 4 image, 2 having a 5 as an image, 3 having a 0 as image. So every element of a having image here. So it means here R1 is function. You can say this R1 is a function. Okay, so it satisfies the definition of function. So now we can call this R1 as a relation, and also we can call this R1 as a function also, because it is satisfying both definition. Relation definition also it's satisfied, function definition also it's satisfied. So it means R1 is a relation, but it satisfied some special type, it satisfied some special condition which I have mentioned in function definition. So it satisfies that definition, so now I call it as a function. Okay, when it comes to R2, if you observe R2 here, okay, here 1 is from A, 2 is from A, and 2 is from A, and 3 is also from A. So first elements are all from A and the second elements are all from B. Okay, but if you observe here these two ordered pairs, if you observe these two ordered pairs here, 2 having the image -4 and the same 2 having the image 5. So here 2 having image -4 and the same 2 having image 5. So it is not satisfying the condition of function. So function says every element of A, okay, every element of A is used, 1 is used, 2 is used, 3 is used, every element of A is used, every element of A has one and only one image in B, but here 2 having 2 images -4 and -5. So it is not satisfying the definition of a function. So here we have to write R2 is not function. R2 is not function. You can say easily by seeing the ordered pair. If order pair contains first elements is repeat, if order pair repeating the first element, then directly you can write that relation is not a function. So if the relation should be function, means the order pair should be, first elements of order pair should be different and all elements of A. So here order pair, all elements of A are present, 1 is present, 2 is present, 3 is present, but here 2 is present twice. It means 2 having a 2 images. If 2 present 3 in a 3 order pairs, means 2 is 3 images. So how many times it repeats, that many images we can consider. We can see that many images here. So if 2 here having a 2 times, so we can see 2 having a -4 as image, 2 having a 5 as image, so it has no one and only one image, so it is a not function. Okay, I hope you understood how to find from relation to function, how to check the given relation is function or not. Okay, next we should know about the domain and range here, domain and range concept. So I have written here, so domain is nothing but for this R1, the initial point, the starting point where the relation is started. What is the most important to create a relation, means starting point. So here the starting first elements of ordered pair are 1, 2, 3. Those are the domains. So in domain I am going to write 1, 2, 3, 1, 2, 3. Okay, so and range of R1 means where it reached, its relation is started and where it ended, that is important. So from 1 it is started and it ended in -4, 2 is started and it ended in 5, 3 it started and it ended in 0. So where the relation starting point is domains, the relation ending point is range. So it's range here. So range of R is nothing but here -4, 5, 0. So this is range. So domain of R2 means, so domain starting point, here starting points are 1, 2, 3. So in set we are not writing a repetition, so in the sets repetition are not allowed. So in set we have to write differently, 1, 2, 3. We have used 2 times here, but also we have to mention only one time. So range of R means second elements 5 and -4. The 0 is not used here. Okay, 0 is not used in B. So it means, so here domain means it, we have to check in B. Range means we are going to check in, domain means we are going to check from A, range means we are focusing on B. Here domain means we focused on A, range means we focused on B. Actually R2 is a not function, but we can find a domain and range for a relation. So I have found a domain and range for relation, but here if you observe I have found for both domain and a range for a function as well as a relation. Okay, so don't confuse here, domain and range can be found for both relation and function. If it is a function, then we can find a domain and range. So if it is function also, then also we can find a domain and range. Okay, here R2 is not function, but also we can find a domain and range. Domain is nothing but a starting point, range is nothing but a ending point. In the given relation, the first elements of order pairs are nothing but domain, and the second elements of order pairs are nothing but a range here. So that is what I am going to, that is what I explained here. Okay, domain and range are nothing but first elements and second elements. You just focus on those two in order pair, just focus on first and second elements. First elements are come from the first set A, second elements are come from the second set B. That first set is nothing but a domain, and that second set is nothing but a codomain. In codomain we got all these relations. Okay, so now let's understand by the help of arrow diagram. So we are going to understand easy. So here for A we having 1 2 3. Okay, B we have minus 4 5 0. So in R1, so if we consider R1, if we consider R1 here, 1 is related to 1 is related to 1 is related to minus 4, 2 is related to 5, 3 is related to 0. Okay, 3 is related to 0. So here domain is nothing but this, but domain is nothing but this is the domain. This is the domain part. So this whole set A, this is domain. So if you ask a domain of a function or domain of a range, means you have to focus on the first set. First set whole thing is a domain here. So if you want to check the range, you have to check it in codomain. This actually B is codomain. Okay, actually this B is a codomain. So here codomain range is nothing but we all we have used. 1 is used minus 4 as image, 2 has used 5 as image, 3 has used 0 as image. So this minus 4 5 0 is a range. So this is range. This is range. In second example, R2, this is A and this is B, this is R2. Okay, this is R2, 1 2 3 minus 4 5 0. So in second example, if you consider 1 5 2 4 2 5, 1 is related to minus 4, 2 is related to minus 4, 2 is related to 5, 3 is related to minus 4. So 3 is related to minus 4. So actually it is not a function. Okay, not function. But if you observe domain 1 2 3, range means only minus 4 5. So this 0 is not in range, but actually B is a codomain. Codomain means second set. First set is the domain, second set is the codomain, and this minus 4 and minus 5 are only range here. So 0 is not comes under the range. I hope you understood this. So let's see another example also. If I consider another example, this A, this B, this is R3, 1 2 3 4 5 6 7 8 is there. So 1 is related to this, 2 is related to, 3 related to this, 4 is related to this. Okay, so now range is 5 6 8. So 7 is not used. So if a 7 is not used here in second set, means that is not comes under range. So when you check for codomain, so here codomain is 5 6 7 8. Codomain is a 5 6 7. Codomain means we have to say all the elements in set A. Domain means, see, domain means 1 2 3 4. In this domain means we have to say all the elements of A. All the elements of A is a domain, and all the elements which are used, only those elements are range. Here 5 is used, 6 is used, and 8 is used. So 5 6 8 are the only range. So if you consider both used and not used, then we call it as a codomain. Here 5 6 7 8, everything is a codomain here. It means we can say, so here 5 6 7 8, 5 is used, 6 is used, 8 is used, so we call it as a range. And codomain means whichever elements we are used in B and whichever elements not used in B, we have to write all elements, second set, 5 6 7 8, 5 6 7 8. This is codomain. Domain means first elements. They all elements of first elements, 1 2 3 4. These are the first elements. Okay, so if you observe here range and codomain, range always comes under codomain. So range is a subset of codomain. Range is a subset of codomain. So we have to know range is always a subset of codomain. Range not overcome the codomain here. Range always contains in a codomain or it matches to codomain. Here see range and codomain are equal. So codomain means we are going to say -450. Range means we are going to say -450 because these three elements are used in set B. So codomain and range are here equal. Here range is a subset of codomain. So you should understand range is always subset of codomain. It means it contains in codomain or it can be equal to codomain, but it doesn't overcome the codomain here. Okay. So if we have already discussed this R1 is a relation, no? So we can, this R1 is also function. So this R1 is function. R1 is function. We can write this function. See, 1 is related to -4. No, we can write like this: f of 1 equals to -4, f of 2 equals to 5, f of 3 equals to 0. Ordered pairs, whatever the order pairs we have written, 1 comma -4, 2 comma 5, 3 comma 0. So those are ordered pairs. We can write like this in function format: f of 1. F of 1 equals to -4 means if we input the -1, we get output as a -4. Let us think like this. So f of x equals to y. This x is nothing but input here. This x is nothing but input and this y is nothing but a output. This y is nothing but a output here. So f is a denoting it is a function. This f denoting as function. So it means in function, if you input a some value, we are going to get output as a y. Okay, so we denote a function as f of x equals to y. This x comes from domain. This x comes from the domain, and this y will be in codomain. This y will be in codomain. So this we have to know. This we have to know. F of x equals to y. We will write f of x equals to y in upcoming videos. I am going to explain and I am going to solve the problems based on like this only. So in that we are going to write like this: f of x equals to y means this x part indicates the input. We are inputting something and we are starting something here. So after inputting we will get some value. We will get some output here. So for that input we take that input values from the domain and we get those output values which are in codomain. Okay, so whenever they ask to find a domain means we have to focus on this x value. Whenever they ask to find a codomain or range means we have to focus on this y value. Whenever they ask domain, we have to focus on this x. Whenever they ask about range and codomain, we have to focus on this y. Just imagine like a machine. It is f of equals to f of box equals to this box. So it is working like a machine. Okay, working like a machine. We are inputting here something and it outputs something. Okay, so this input value will be domain and this output value will be range, which is in codomain. Okay, so this, I hope you understood the domain and codomain, range, some basic concept. So in next videos we are going to use this basic concept and I will also explain and also how to solve the problems also. So by domain, codomain, range, from this concept we can expect a CET question also. Okay, I hope you understood this topic, domain, codomain, range. So if you have any doubt, please comment in comment section. So I will clarify there, or I will try to explain you in the next video if you not understood. Okay, bye. We all meet in next video now.